Hi, my name's Adam Greenblatt, and welcome to Industry Insights, a video series where we interview leaders about key trends and topics impacting their respective industry. Joining us for today's discussion is none other than Bill Kleyman, CEO and co-founder of Apolo, an AI platform and infrastructure company. When I think of who has the pulse on the data center industry, Bill is on a short list of trusted technologists and influencers. Ranked globally by Analytica as one of the leading executives in cloud computing and data center security, Bill focuses on advising organizations, training young talent, and educating global audiences about AI, machine learning, sustainable data center design, and cybersecurity. Bill, welcome to Industry Insights, and thank you for sharing your expertise with us today. It's great to have you here.
It is a pleasure to be here, and what I can feel that came from the soul, man. That was not ChatGPT written
No.
whatsoever. That was I felt the energy in that presentation as well. My gosh, it's like a real live broadcast.
Well,
Thank you.
we are here
Yeah.
because we've been talking about sitting down and talking with you for quite a while. And it's a pleasure to have you. We know you're a Chicago resident. We're in our innovation center here.
No bags packed, no airplanes, no TSA lines. I got in my car and I drove here, and I feel refreshed and ready to go.
And here you are. And it's a beautiful Monday morning on a holiday week.
That's right.
So thanks again for coming. So many different things we can talk about. You've got fantastic background and insights on everything that everyone is talking about in the data center industry.
Yes.
It's amazing because 10 years ago, those that were in the space would talk about it, but now everyone's talking about what's going on because of AI. So a lot of different things we'll talk about today, right? But let's start the conversation a little bit more about your background and how you got to know all of us here at Wesco.
Yeah. Oh my gosh. We go back. Actually, probably my first introduction to the team here was through Annixter, and some of the people that are in the room with us today. But my introduction to the wonderful group at Wesco was through my relationship, obviously, in working in the data center industry, through what Annixter is doing, and obviously the wonderful joining that we saw, that we now see is proper Wesco. But I got my start in the industry just really quickly. We talked about it briefly, Adam. I'm from a different part of the world. I was born in Kyiv, Ukraine. And back in Ukraine, my brother used to compete in telegraph competitions, like literally Morse code, right? So I was 8 years old. He'd put these giant cans on me, and I learned about communications through beeps and boops, right? Like Morse code and whatnot. Now, it's not the only way we communicated. I know it was Soviet Ukraine. We had a phone on the wall. We couldn't, just talk to people that way. But my gosh, that was the most fascinating way of at least for an 8-year-old, the way we talked, vast differences covered with nothing but dots and dashes. And I took that love of connecting people, connecting infrastructure, seeing how that works, and I carried it over to the United States, went to school for this stuff, network engineering, telecommunications undergraduate, MBA in business, and other master's in information security. But my gosh, in 2004, I started working in data center. No, they didn't even call them data centers back then. They were like network rooms and data closets, right?
Yep.
The word data centers wasn't even like cool back then, right? But that was my love and my passion, creating these architectures, connecting physical systems together, vast networks. And fast forward to right now, what a wild moment this industry is having. I'm having so many conversations, much like folks like you at Wesco are right now. What is a data center? What are the different components that fall into it? And you mentioned the lecturing that I'm doing. Some of the most inspiring work sitting in front of students who are electrical, mechanical, computer engineering. And now we actually have a program with Texas A&M out in Texas, obviously, but policy students, literally not a single thing about technology. All they do is develop policy, and now we're introducing them into the world of data center. So very long-winded answer. The way I got introduced to Wesco was through my experience, obviously working with the wonderful folks at Annixter. Now I see what you've become, and it's wonderful to have you as partners and friends.
That's wonderful. And you have seen the dawn of the internet era all the way through now what you would call this next kind of cycle that we're in, right? Some people don't even take a step back, to your point, and realize like what we're in the middle of. So let's talk about that.
Sure.
Estimates of what will be spent in the coming years on data center projects go from hundreds of billions up to, depending upon what report you want to read, trillions of dollars, right, through 2030 and beyond. And I've heard you say that every data center will become an AI data center. So if it's inevitable, what's it going to take to make that happen?
Oh my goodness, Adam. We're gonna talk about a few things today, right? And I promise this is not coffee in here anymore. It's water.
Mhm.
They wouldn't give me any more caffeine because they're like, Bill, we're not gonna be able to slow down this reel enough for people to understand you. Um, what we're seeing in this industry, and everyone can go on their favorite search engine, right? ChatGPT, whatever it is now, and ask the question how much is being invested, and you're going to get, billions of dollars, right? And some are going to say it's $1 trillion industry, and we were all worried that there was going to be a bubble, and yet Nvidia came out literally this week. If you guys are watching this, literally this week, Nvidia came out. I'm sorry, late last week with their earnings report and said we're doing just fine, champ. We don't know what a bubble ultimately looks like, and whether we do or don't discuss that, that's fine. But the data center industry, people call it, transformation, revolution. I consider it a renaissance. Um, the metric that I want everyone to sort of wrap their minds around is just how vast and how quickly we became noticed
Mm.
and how much investment in infrastructure is happening. So I just got back from the Schneider Electric Innovation Summit, and we got the latest estimates of how much our industry, Adam, you and me, the data center space, is going to consume in terms of power by 2030. Okay. Now, just to preface this, I am writing a book. I'm sorry, I have ADHD. I can't write a whole book. I can write chapters in books. That's the amount of my attention span can last. I'm writing a chapter in a book called Greener Data Volume 3. It's being released by our partners JSA. Um, and I wrote the first a chapter for the first one, became an Amazon bestseller, wrote the second one, volume, and now we're out to the third one. About 4 weeks ago, I put an estimate of how many gigawatts our industry is going to consume, right? And that estimate was already off in the final almost printing. I'm like, wait, before you print this thing, here's the updated metric. So just getting back from the Schneider Electric Innovation Summit, this industry is slated to consume by 2030 200 gigawatts of power. 200 gigawatts of power. Now, I know there's a lot of people listening to this. It could be marketing and finance, right? Whether you're an engineer, whether you're not. I want to put that in context, what 200 gigawatts of power in the next 4.5 years means for our industry. So 1 gigawatt is enough for about 1 million people. 10 gigawatts is enough for about a Los Angeles or New York City. And 100 gigawatts is about 10% of all the lights that are currently on in the entire world. So when someone comes to me and says, we're going to require 200 gigawatts of energy in our industry, in the United States alone, by 2030, my immediate thought is, so you want me to build you what, enough power for what, like 10, 20 LAs? Like that's 10 to 20 New York cities? How is that even possible, right? So we get into these conversations around behind the meter power generation, new types of energy sources. So the answer to your question, just how big are we becoming? What is happening in the industry? We're no longer a place that no one knows about. I've been having so many of these conversations. You mentioned that I'm an influencer. I'm okay with this term. It took me a while to become,
Yeah, you mentioned that. You
I
got to get acclimated to
I like to consider I'm like the Steve Irwin of the data center industry. Like, oh,
good analogy.
look at that server. Let me go press a button just to see what happens. I'm still working on my Australian accent. Please don't quote me on that one. But it's fascinating to be in this space, and there's a lot of growing pains. There's a lot of really big questions of how are we going to get there. And the biggest kicker right now is understanding the infrastructure, the partners, the components, right? We're sitting in this wonderful location here in Wesco, and there's a really cool innovation center right around the corner where you can see the liquid cooling, the power technologies, the concrete slab raised floor architecture that's going to be required to support new levels of cooling, weight density, power distribution. My goodness, everybody, the average rack density in the data center right now is about 15 kilowatts per rack. But you see Jensen Huang from NVIDIA coming out and saying, we're going to be releasing the NVL 572, which is a data center rack that's going to be consuming 600 kW, 600 kilowatts per rack, where our industry average is scratching at the door of about 20 kilowatts per rack. How do you get there? And this isn't just like a nice to have. These are true existential questions that many are asking. What are the ingredients of this thing called an AI factory? How do we ultimately get there? How do we support new power systems that are moving from AC to direct current to DC? And all the questions around weight and water, power distribution, and environmental elements as well. I don't know. I'm an agent of change. I kind of love this stuff in case you can't tell, but for some people it's a lot of growing, it's a lot of questions to ask and answer as well.
Well, I think there's parts of the industry that have plans in place, and a little bit I'll say we're probably building the plane as we're flying it, right? Which is the reality, I think, considering the speed that things are moving. But you talk about the power utilization. The other
Yes.
thing that we talk about, you have to have a conversation about, and you've talked about, is sustainability.
Sure.
And you mentioned earlier policy, right? New possible ways to make all this possible. But do you believe this is sustainable? And at the same time, what are your thoughts about concerns you have about how we're going to reach things like a 600 kilowatt, right, rack? What's even, frankly, possible?
I just spoke at the event recently in Las Vegas, the Schneider Electric Innovation Summit, and I quoted myself saying something that people kind of wrap their heads around, and it's fearless curiosity. That's what you have to have, right? And I firmly believe that in the industry right now, you need two things to be successful. You need power and you need bravery, right? And that's what we're seeing on display right now in terms of what we're deploying, the kinds of systems that we can ultimately deliver. But like we talked about earlier, it's a true existential situation, right? People need to understand what can we possibly bring in and how can we support these kinds of systems. I want to make sure I didn't forget your question. Could you ask that one more
It's just
time?
about sustainability
Right.
when you talk about that, the power utilization element.
I don't want to ignore the sustainability question. I was about to get off on a tangent. Like there was an important point in there around how do we keep things sustainable. So at the AIDC conference in Phoenix, we had Crusoe sit on the main stage, and this was their one of their senior developers, right? People actually building the construction, the architecture. Fearless curiosity really translate in our industry to do things that maybe you never thought you'd be doing for things like sustainability and expanding capabilities for physical infrastructure. And that means partly designing things that you've never designed them in a way that you're doing it right now, right? Obviously, bringing water and liquid cooling, right? Using closed loop systems, understanding how do I impact less of the water architecture? How do I, become a better neighbor to different kinds of places that we're building. Look, we're actively running out of capacity in our primary markets, right? There was a JLL report recently that said that the active vacancy for tier one primary markets, Northern Virginia, is less than 1%. Adam,
Data
that's
center alley right
yeah,
there.
that's nothing. That's literally nothing. 2 to 3% in let's call them NFL cities, right? So you're seeing secondary markets become primary, tertiary, secondary, and so on. Let me bring up that Crusoe example really quick for you, right? This facility is one of Oracle's largest, right? They're going to be the ones that have about 500,000 GPUs training the Bix Next foundational model. And they went above and beyond in terms of designing an architecture to focus on sustainability, efficiency. How do we create an environment that's conducive to this thing called an AI factory, which I'm not entirely sold on that term yet because there's really nothing clean about factories, right? So maybe we'll think of something better. But first of all, even though it's called Stargate, they have what's known as a star configuration, right? So if you ever take a look at the design, it's building 1, 2, 3, and 4, and in the middle is a hub. Now they use that hub for fiber runs because they're trying to eliminate the limitations of a single mode fiber, where those clusters have to be able to connect and contribute and communicate with a central fiber node. So they're building this kind of architecture in a very unique way. Now, here's the crazy part. Check this out. So 1.2 gigawatt facility. Do you know how much of it is actually sitting on generators? 20%. 20% of a 1.2 gigawatt facility is sitting on a generator. Whoa, 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 whoa. Pump your brakes. You're talking like not full redundancy. Well, the gentleman from Crusoe explained, like, here's the kicker. The only stuff that's sitting on those gen sets is going to be the cooling, the networking, really critical componentry. But if the GPUs go down, just pause the training, wait a little bit. When the power comes back up to those GPUs, we just reset and we continue the training. They pause it, right? So now, all of a sudden, we have this conversation, this shift in a paradigm of working with an architecture that doesn't require gen sets for the entire
The whole definition of what was considered uptime has changed.
completely changed, right? But now you're much more economical. You're way more environmental friendly. You have to test out way fewer gen sets, right? You require way fewer diesel fuel, gallons of diesel fuel in the actual site. And this is an extraordinary moment, right? I'm saying this, and a bunch of people are going to be like, well, Bill, this makes sense. The crypto people have been doing this for forever and some of these other ones. But in traditional large-scale data center operations, some of this is new. Powering and backup gen for only 20% of your entire physical architecture? Yeah, absolutely. There's a great saying right now in terms of what we're seeing right now happening in the industry, Adam, and everybody listening. And some folks have heard me say this analogy. We live in a world that's just discovered oil, but hasn't invented the internal combustion engine. All this raw material, and no one really knows what to do with it, right? And just like this thing, oil, it's in everything, right? It's in food, it's in medicine, it's in M&Ms, the red ones, and everything. It's in shoelaces, right? And where we are in this industry right now is how do you get from a barrel of oil to a shoelace? Not just any shoelace, which is the big question all these analysts and investors are asking. A shoelace that doesn't cost you the entire shoe, right? Or the entire shoe store, excuse me, one that actually can tie a shoe, right? So we're trying to figure out all of these questions. And like you mentioned, as a part of it, building the infrastructure as we go along. There's an open known statement. We're asking our systems to do things that they were never really designed to do, ultimately, right? Which is why these H100s, they sound like jet engines when they're up at full swing. But these future designs, all liquid cooling. And that's not a question anymore. It is an imperative. Like, liquid cooling is not a nice to have. If you're going to become an AI facility, that must become a part of your environment. That's before we get into too much trouble. That's not Bill Kleyman saying airflow is going away. We still need airflow and airflow systems in there. But if you're going to become and designing around an AI-ready architecture, you have to think about water manifolds. You have to think about copper piping. You have to think about gap gauges and fittings and pipes, things you may have never thought about putting in a physical facility, and obviously liquid as well.
And all of the applications traditionally people, I would say, outside of the space think about what they've interacted with around AI, aka platforms like chat or others, right? But the reality is you've talked about applications that are very much different than what people today traditionally experience. In the same vein, that then turns to the idea of democratizing, right, AI or the data center capacity and making sure that it's being used for, quote, the greater good. Do you have thoughts on that? What does that even look like?
It's a rising tide situation, and while we're trying to float all boats, the boats are different that are trying to float out there, right? The market is broken down into three really big categories. And I want really everyone to understand this because this will define what we're going to see the next, let's say, 24 to 36 months. There are the Abilene, Texas of the world, big 1-2 gigawatt facilities, right, which have 500,000 GPUs. They're building the next foundational model, right? They're out there trying to inject ChatGPT, Llama, Bard, whatever, right? Now, from an Apollo perspective, that's not what we necessarily focus on, right? The middle part of the market is enterprise large language models, right? Big organizations that say, I need a little bit more horsepower than just traditional inference, but I don't need 100,000 GPUs. I need 5, 6, 7,000 to build my own enterprise LLM. Now, that's another big part of the market. And finally, what I think is going to be the biggest part of our industry is going to be inference, the practical application of AI, these LLMs to real world use cases. In those situations, you might not need a few thousand GPUs. You might need a few hundred. Now, we have a few thousand GPUs under our management, all sorts. We're hardware agnostic, spread around the world. But we're not out there trying to build the next foundational model. We're actively trying to apply these things that have already been built to real world use cases. Now, talking about doing something for the greater good, the entire premise in designing an architecture, it has to be green to some extent, right? The premise behind building an AI facility, you have to look at ways that are more efficient around power distribution, power and efficiency, land utilization, the kind of componentry that you're building into this. The good news is that this industry is actually, they care. They want to do the right thing. They want to be good neighbors, right? They want to be like the water tower or the hospital, the municipal building that's an active part of the community. The bad news is we're not really good at PR. We're not really good at getting the message out there. And so remarkably, as an influencer, I'm having so many more of these conversations out there with so many more people. But unfortunately, the first question that I get is, Bill, why do you consume so much water?
Yeah.
Bill, you're taking all the power and electricity. in all of our neighborhoods. Bill, you're making my rates go up, which is it's actually inaccurate. So I spent some time listening to the executive brief from Rob Roy, the CEO of Switch, over at the Schneider Electric Innovation Summit, and he pointed out a wild fact. Switch uses a third of all of the power in Nevada. A third of all of the power in the state of Nevada, right? And remarkably, they're actually partly responsible for reducing the rates for the ratepayers, the electricity and power ratepayers in the state of Nevada by being more closely aligned with the utilities and commissions. That is so incredibly cool. Now, they're not the only ones that are trying to go out there and do that. Now, we need to create better policies, which is why we're working with policy students. But for the greater good, our industry isn't only power consumers anymore. We're also power producers, right? In the reality that we need to be able to connect to the grid, we need to, in some cases, put power back into the grid, and we have the full capacity to actually impact grid operations to lower the cost, to put more green, sustainable energy back into these fields, and actually work with utilities and commissions. Now, there's some growing pains. This is net new for so many different kinds of industries where, in the past, an entire campus was 100 megawatts. Now it's just one building. One building is consuming that much. So the concept of being a better partner for communities, for the environment, for schools, for municipalities, everything, that's honestly encrypted, to use a technology term, in the DNA of my organization, right? It's a reason why I personally am involved with so many different philanthropic organizations, to working with students, everyone from like K through 12 in college and graduate school and beyond. The challenge is messaging, man. We were built as these nondescript buildings in the middle of nowhere. Don't tell anyone what's in there.
No one knew what it was.
Just tell them it's a warehouse. The clients don't want anyone to know. And that has bit us in the butt and shot us in the foot. Use whatever analogy you want. Whereas right now, listen, I'm a geriatric millennial. I don't know why they have to use that term. It's unnecessary. You could just call me an older millennial. But we are having a challenge in getting our message out there to many, many people in the industry. Now, again, very long-winded answer. The greater good concept is there. We just need to be getting much better at messaging it. We need to get much better at helping people understand that there are NIMBYs, right? Not in my backyard. There's a recently new term that I learned. It's called NOTE. Not over there either, which...
Interesting.
Friends, at this point, give me all of your electronic devices. Here's a piece of paper and a pencil. Good luck to you. But having those meaningful conversations, not adversarial, right, but truly cooperative and collaborative types of conversations to understand what these concerns are, because they're legit. How much water are we using? Are we impacting your rates? Are we building these things too high? What are the sound levels and decibels? And by the way, I have conversation points around all of those. We just have too much time to get into that today. But these are... none of this is going to slow down. Listen, South Park is doing, and this is the rare moment that I actually reference this, that South Park is doing episodes on AI and data centers, and I'm getting questions from young people, hey, Bill, I saw South Park doing an episode on AI. Can you tell me about that? I'm like, oh my gosh, I have to reference Kenny and Cartman now all of a sudden to give you an explanation of what data centers do. And you know what? That's great. If that's my entryway to this market.
And that means that everyone's talking about it, but back to like what this is going to take, it's going to take advocacy, communication, and building this ecosystem, which is one of the reasons we wanted to sit down with you. I mean, we've said for a long time, there is no lone wolf in the data center industry. You can't go and build and power and tune up and operate one of these facilities, quote, by yourself, right? And I think the industry will continue to evolve and change, right? And move at the speed that's necessary. But when you think about that speed and you think about what's being required, right, let's talk a little bit about the solutions. And you started talking about some of these new solutions, right, that are going to make all this possible, right? We all talk about HD or liquid cooling and the opportunities there. So if you want to expound upon that, you can. But what are you seeing from some of the leading organizations, not even the brands, but like from a net new technology standpoint? Because I've talked to folks and they said, oh, well, yeah, liquid cooling's been around for a while. Okay, yeah, it has, but it hadn't actually had that kind of, bridge to where we're at today into the last 24 months. So like, what's the next thing? Do you see something beyond that?
Yeah, listen, we're going to do the chicken and the egg conversation. The egg in terms of liquid cooling is from IBM AS400s, right? The mainframe systems were the original OGs that broaden liquid cooling, number one. Number two, for the fans of that kind of architecture, also introduce virtualization, multiple users on one system, right? Using different kinds of pieces and applications in the environment. So you're absolutely right. Now, for the liquid cooling purists that I know are going to listen to this, I've received flack for saying that rear door heat exchangers are liquid cooling. Bill, that's not real liquid cooling. All right. It's a car radiator that's slapped on the back of a data center rack. Fine, right? But the premise here is that we're bringing liquid cooler to the source, right? So let's talk briefly about the components, and we don't need to name brands. There's many wonderful ones out there. There's different parts that need to fall into place for a data center to, like we talked about, to become an AI data center. When we sign on partners, we have a very short list of what you can and can't handle to be able to support H100s, A100s, B200s. All of these new kinds of systems are coming online. And this is a moment of realization, introspective moment. That's the word I was looking for a lot of these facilities to really answer the questions for themselves. If I'm raised floor, can I handle the weight of these racks? And in the bittersweet moment is sometimes if you're at 3,000 pounds per square foot, maybe you can't, Adam. And that's a question you need to ask. Can you run water manifolds? Do you have some kind of a closed or open loop system that you can eventually introduce? If those are all no, you will always be limited in terms of what you can deploy. And for the folks listening, I just need to put this in perspective, why this conversation, why these parts and components are important. You heard me mention earlier the average rack density of a data center rack right now is about 15 kilowatts per rack, okay? So it's standard 42 unit rack. You can go on your favorite search engine to see what they look like. One single NVIDIA DGX server, which has 8 H100s, costs about as much as Lamborghini, that consumes upwards of 11 kilowatts for just one. So if your entire rack can do 15, what do you do? Put one in there and a whole bunch of blinking panels? That's just not going to work, right? So you have to be thinking in the 40, 50, 60, 70 kilowatts per rack, which is at that point really in the introduction of heavily containerized, isolated systems if you're just doing airflow, or really working with liquid cooling, some kind of a rear door heat exchanger architecture, right? The other reality is being able to bring in power systems, PDUs, battery systems that are capable of handling this load. Because look, the reality of the situation is if you lose a pizza box server that had, some web app on it, oh no, $5,000 down the drain. If you lose a single H100, that's a really expensive Toyota Corolla. That's like a $30,000 to $40,000 card for one. Imagine seeing what an entire server goes down. There's a new term I'll teach you. It's called an RGE, a resume generating event, right? And that's not something anyone wants to experience, right? When you lose an NVIDIA server simply because you didn't look at how effectively you're supposed to cool it. The core components that we've seen are: can you handle the weight? Okay. Can you cool it? Okay. Can you bring in the power infrastructure to support these new types of racks? Okay. Do you have the networking architecture to support this, right? Whether it's InfiniBand, Ethernet, Spectrum-X, however you're going to be designing, are you able to make these things run as a cluster? Okay, right? And then ultimately understanding how you're going to be designing and deploying this stuff to support a customer base, which right now is still learning how to use AI, right? We're still sort of walking this. Now, again, we don't have time to get into this. People are welcome to go to our website, apollo.us. We're working on extraordinary use cases for government, municipalities, the federal government, zoning, all these different kinds of real world use cases to prevent building an elephant on a unicycle. Looks great for you, but does nothing for your business. That's where we're at with this world. Now, these pieces of infrastructure that we're talking about are going to have to support that. The list to go after AI is not long, but if you're missing one of those components, you're going to have to pause on deploying some AI componentry and building into it. Now, the biggest success points that I've had are data centers that are doing hybrid, right? They are traditional air-cooled, 15, 20 kilowatts per rack that understand I can deploy this in a part of my environment, a segment, maybe I can dedicate 5, 10, 20 megawatts of my facility to AI-capable solutions. That's fine. You don't have to build out an entire hall or an entire new building just for megawatt. You can actually convert what you have right now. That's been the best approach. And honestly, it all starts with, can I handle it? How do I bring in customers? How do I monetize these kinds of solutions? And then ultimately you're off to the races.
So definitely different requirements, right? Depending upon the legacy infrastructure and architecture, as you said. But the big hyperscalers have been planning for this. They're planning every day and how they're going to invest and move quicker, right? And move faster, right? But then the other segment of the market that we've been talking about, a little bit indirectly, here's the colocation market.
Right.
So can you talk to me and the team and everybody about the different architecture needs? And a lot of those facilities, legacy facilities, are not going to be able to do what you were just describing. So what's being done there? What are you seeing happening?
Oh my gosh. In case you can't tell, I'm a very positive individual, but this question specifically, underneath this shirt are a whole bunch of bumps and bruises that we've been trying to answer this specifically, right? Um, it's important to note. So my company, Apollo, my clients are data centers, telcos. That's my client. All right. I don't really work with the hyperscalers. My target customer are the ones that you said, colo. So now the question is, cool, Bill, how are you in business and how are you converting these traditional colos legacy into AI ready infrastructure, right? So by nature, my company Apollo, we are a factory floor. Consider us that way, right? We are the industry's only true white label multi-tenant platform, AI platform, which is a whole lot of words. A colocation goes out and buys GPUs. They put Apollo on top. Boom. They have their own little neo cloud in a box, a mini Amazon, because the colo clients have, let's say, 100, 200 enterprise customers who a bunch of them can't go to the cloud. Proprietary, can't even use Copilot, right? They need to use AI right where their data is already living. Now, these co-location providers, their options are limited. Yeah, they can get the GPUs, but then what do they do with them afterwards, right? It's a GPU by the hour or maybe bare metal. But in our situation, they rip a page out of Amazon's book and they offer hyperscale level services because our platform does billing, networking, all that ugly back-end plumbing like ticketing systems so that the co-location can only become like a legit little mini neocloud in a box and get all that revenue from AI. This is not a SQL box anymore or email server. The revenue multiples are massive. Now, that's the good news. The bad news is, how do you get there, right? Ultimately, how do you ultimately get to that kind of a point? Sometimes it's bittersweet. I don't know how else to say it, Adam. Sometimes it's a realization that maybe they're not quite ready to support this kind of environment. Because realistically speaking, out of 10 data center providers that we talk to, 20%, two are legit. Like, okay, Bill, we can invest a couple of dollars, small modifications. We can start putting AI infrastructure in. Many of the other ones are simply unprepared, whether it's ceiling height, whether it's weight capacity, whether it's water, whether it's power systems being brought in. All of those are critical components right now to build a rack that's capable of supporting AI. Now, in our situation, what Apollo does is that we don't put everyone on H100s. We have, V100s, A100s, stuff from AMD, all different types of processors. So we know the workload and what it should live on. But that doesn't negate the fact that we still need data centers and that underlying infrastructure. The hyperscalers, you're right, Adam. They're good at this, man. They've been launching this stuff. They have single tenant clients. They are so incredibly good at this. But just like when the internet came out, the hyperscalers wrote the rules. They did, right? Leaving us in the data center industry to host traditional VMware, Citrix, virtualization, email boxes, database servers. And what's maybe a little bit heartbreaking is that the exact same thing is happening right now, but you have a market that doesn't necessarily want to go to the cloud. Not all of them want to go to these hyperscalers, right? They want to stay in the co-location environment. So imagine just how quickly these traditional colos have to grow and change and revolutionize, experience their own little renaissance to support these kinds of requests. The client base is there. In the next 24 to 36 months, this 80% training, 20% inference is going to flip right on its head, because eventually these investors are going to be like, cool, we built all these foundational models. Can we make some money off of them now? Can we actually see what they're doing? And so that is going to flip, where we're going to still see a bunch of money invested into training new foundational models. That is that 20%. But that big chunk of 80 are going to be applying it. revenue generating use cases, agentic AI, AI apps that are living in the data stream of these small, mid-sized, as well as big organizations. I mean, that's the kicker. These tools, for the first time ever, allow a small and medium-sized organization to compete at the level of the Fortune 100s and Fortune 500s without having to invest millions upon millions of dollars. That's the power of generative AI. But they're going to look to their colocation partners, where their data is already sitting, to be able to support those kinds of workloads, because it can be a lot less expensive. It can be a lot more trustworthy. It's certainly a lot more secure. And in many situations, through a good colocation provider, more sustainable as well. The question is, how quickly can every data center
How quickly
become
is
an
it
AI data center?
correct? And that's
Yeah.
it's gonna require everybody working together.
Speed to
But it's
market.
also gonna talk, going back earlier, talking about where. And you were talking about available capacity in what we call Data Center Alley in Virginia or in the other NFL cities. Myopically, here we are sitting in Chicago. But can you give your perspective around the globalization element and some of the other areas throughout the world that you expect to see tremendous infrastructure investment, right, to bring this capacity to, as you said, every kind of organization?
What a great, great question, Adam. And I can't stress this enough. We are seeing so many emerging markets, and I love it. I'm an agent of change. We've got like a map there behind you,
Yeah.
and I've traveled all the way from the West Coast, from Chicago also, to beautiful New Zealand. It's a 17-hour flight. Holy cow, if that's a test in resilience. But I landed in Auckland, and my gosh, were we talking about data centers in the Southeast and the Asian Pacific market, because we're going to see that kind of expansion. But in the United States alone, secondary, tertiary, fourth level markets are absolutely coming online, having conversations in North and South Dakota, Wyoming, West Virginia. At Data Center World, we had Governor Mike Dunleavy from Alaska coming up on chair and saying, build data centers in Alaska. And he had every single list checked off, marked item check off, like power, water, land, availability, all this. And one of the things they have to work on is connectivity.
Right.
They do have to work right, because right now I'm pretty sure it's like a husky running around with an Ethernet cable. If you want to connect to the internet, you got to catch the husky. I'm just kidding. It's not that bad to my Alaska friends that are listening. I know you guys are investing in cable drops and new fiber runs, so it's going to be wonderful. But Alaska is a great market, a great place for you to come in and build your next AI factory, right? Maybe you don't need that latency right now with the connectivity, but you can put 500,000 GPUs in a place where, literally open your windows and you get free cooling. Don't do that. That is not something Bill Kleyman is recommending. I just want to quickly say, do not open your windows in your data center. Make sure you keep those ambient temperatures and humidity in control. But like everywhere in the United States, my biggest partners for Apolo aren't in the NFL cities, Omaha, Lafayette, right? West Coast, in Texas, and all of these new kinds of emerging markets. I'm excited about that. I'm excited about seeing these net new places open up. Now, the really fascinating part is that in these parts around the United States and the world, specifically the US, there are energy and power cooperatives that are so incredibly amicable to data centers, business climates. There's a lot less regulatory tape you have to jump through, and many states have great, vast amounts of stranded natural gas. For example, Kevin O'Leary is building his 8 gigawatt Wonder Valley project out in Alberta, Canada, right? And he had everything under the sun. But when he went to the governor of Alberta, he's like, I need 8 gigawatts of power. They're like, where do you want me to get this from? But they have plenty of stranded natural gas. So they're going to be using microgrids and different kind of types of power sourcing to have different power feeds coming into this campus. And that's something we're going to be seeing out here as well. New markets, new power feeds that are going to be coming into data center spaces. But I'm genuinely excited to see many, many more markets opening up. At Data Center World this year, one of the biggest growth points in attendees, investors, and real estate professionals just coming out and saying, we've got hundreds of acres of farmland, or in this location, come build your next facility out there. And you know what? They're onto something. Mr. Wonderful, Kevin O'Leary, flat out at Data Center World said, unless you're investing in real estate and data centers right now, completely missing the boat.
Amazing. So I got one more question for you. We could sit here and talk all day, but I got one more question. And here's the hard one. So pull out your crystal ball.
Okay.
Let's look 5 years in the future. We're having this conversation. Hopefully you can come back. We do it again before then, but 5 years, what does our space look like, and where is the power coming from?
Wow, 5 years.
5 years.
This is less of a crystal ball question and more of like an magic 8 ball question. So I could just shake
Bring it
it,
out.
shake
Bring it
it,
out.
and I'll probably get a better answer than anything out of a crystal ball. 5 years from now, Adam, this is truly a difficult question to answer. Just seeing just how massively quickly this industry has grown. And I really want to put that question into perspective, right? It's January 2023, right? The proverbial dam ChatGPT is just burst open, right? And we see this thing, this tool, this piece of it, this app, right, that has consumed entire markets, right? And going back to your earlier question, as far as where we're going to see these new markets coming up, right? We've got places like India, the most populous country in the world, right? Still consuming maybe 500 megawatts of power. South America is also in like that 3, 4, 500. There's so many doors that are about to be open. But when we start to take a look at this little generative pre-trained transformer, this tokenization, this architecture there's no going back. So let's answer this question with a point of right now. There's no going back. I sat and spoke in front of a room of a few thousand people and confidently said that every single person in that room is a user of generative AI, right? And what's wild is that if they've gone to their favorite search engine, right? Maybe it's Ask Jeeves if they're feeling feisty. I'm just kidding. I used that joke in front of high school students recently.
Probably no idea what
Like,
you're talking about.
what's an Ask Jeeves? Is this guy asking his butler for information? But like, you go to your favorite search engine, Google or Bing right now, and you ask a question, and the first response is not a blue link anymore.
Yep.
It's a generative AI response. We have been trained to interact with data since September of 1998. The first time you could ask Google a question, you ask it a question and you get a blue link back. For 30 years, we've been trained to do this, right? And all of a sudden, it's completely different, revolutionized, where you're not finding a blue link on page 2 anymore of Google, which if you're on page 2 of any search engine, you're lost at this point, just give up. Or you're asking the wrong question, where you're now getting these contextual, wholly original responses. I will answer the question, I promise, but let's put a little pin in the fact that there's been nothing ever in human history that's impacted every single being on this planet as a GPT technology has. And it's not that this hasn't been around for a while. Large language models and generative pre-trained transformers have been around for a minute. We've never had the hardware systems. We've never had the tools, the facilities, the data centers, the models, and the platform to actually make it viable as opposed to now. All right, so let's pin set in the sand. Let's look at 5 years from now. I feel I'm actually going to use a quote from Rob Roy over at Switch. There was a question said that Rob, what's the one thing that you hate about this industry, or not hate, but like a challenge? Said Bill, or not Bill, it was Axios guy. I'm listening. It was the way we measure density in racks is I hate it. Kilowatts per rack. And I'm like, you know what? I think he's right. I think the way we imagine physical infrastructure is going to fundamentally change. The rack itself is going to fundamentally change. Maybe flops per watt, or tokens per second. We measure that stuff in. In 5 years, I feel that we are going to have a breakthrough in the market with small modular reactors. We're seeing 3 Mile Island being renamed. We're seeing things like from Switch being signed up with Apolo. Many other partners are being signed. We had the leadership from Google, from their decarbonization and sustainability group, basically say that we are bringing in our first SMR online by 2030. It's online. It's powering our systems for Google. So I think there's going to be a massive breakthrough in small modular reactors. I think hopefully we're going to see a massive reduction in wait times for natural gas turbines. We're going to have to, because we have just so much stranded natural gas. We're going to see more power production happening from the data center industry. And this is the key part for everyone, not islands of power, but power production that will then be integrated into the grid, right? To create greater grid redundancy. Again, going back to my Switch example, they flat out said that they can disconnect from the grid, and from a Switch production perspective, they can power the entire strip, right? That's how much energy these are going to produce for communities, for resiliency. Also, for example, you can prevent things like brownouts. Now, in the future, I absolutely see in 5 years, we're not even talking like way far down the line, data centers become a bigger part of the energy ecosystem as both consumers and producers. They will be more directly in line and aligned, hopefully, with the energy and power systems, the grid itself, more dynamic, more logical grid architecture. We're going to see way more net new greenfield as well as sort of retrofit architecture to support new types of liquid cooling directed ship. I still feel that rear door heat exchangers are going to be a great way for traditional facilities to enter into a new era of artificial intelligence and supporting high density architecture. Really, that is your absolute fastest leap into supporting 60, 70, 150 kW racks. I absolutely believe that we're going to see AI at the edge in probably not even 5 years, 36 to 5 years, 36 months, about 3 to 5 years or so. We're going to be seeing these smaller, tight 5, 10, 20 megawatt edge inference architectures, really much more distributed globally to support inference at the edge, where this data is going to be produced. I think we're going to start to see maybe a little bit less of a focus on these massive scale AI factories, solely because of the reason that the chips are going to get better. We're just not going to need as much, I think. We're still going to need infrastructure. So I don't believe that there's going to be a bubble. I believe to have a bubble, you need a catalyst, right? OpenAI is a $20 billion business. That revenue is not just going to poof, go away, right? With a platform that's more used globally than anything else. That doesn't just go away overnight, right? So we need to consider what a bubble necessarily looks like. That's not what we want to talk about. I don't think there's going to be one necessarily. In 5 years, the infrastructure is going to look different. It has to. It really has to from an existential perspective. We are going to see true wide adoption of agentic AI. We're probably going to see systems supporting at least some version of artificial general intelligence, AGI. Please don't get scared. We're not talking about Skynet. We're talking about hopefully more like Star Trek, right? I'm a positive individual. Plus, I just came back from a Trekkie conference here in Chicago. Oh, it was so cool. And in case you get to, I'm a more positive individual. And I think these kinds of conversations, and my challenge to everybody here also listening, go out there and be a positive force for the industry so that in 5 years, we're having positive conversations around the good impacts that the industry is making for communities, for schools, for people coming into this industry in this era, but also the positive impacts that we're making on lives, on humanity. What you said was really profound. How do we become an agent for good, for the broader good of humankind? And I feel that of all the technology systems that we've ever had in our life, this is it. This is that agent that can do something special. So in 5 years, the infrastructure is going to look different. And right now, this is the moment. This is a generational investment opportunity. What that means for you, that's your introspective moment to really kind of take away what your shoelace looks like we talked about earlier, what your barrel of oil will ultimately turn into, right? But it's a wild moment. Don't get scared by it. I think it's a fun moment for all of us to learn something fascinating and new. But 8 Ball shaking it, it's gonna be pretty different.
Shaking it up, and today, and you just talked about it. It's about education, communication, and leading from the front. And we're going to continue to talk about what do we need to learn. I learned a whole lot sitting and talking with you today, so it's been awesome. And hopefully we can have another conversation again soon. And like I said, not 5 years from now, because I bet you what we think is not going to be what is going to be reality.
You blink.
It's so fast. It's so fast. But Bill, thank you so much. Really appreciate it. And thank you again, everybody, for joining us for the Wesco Industry Insights series. To learn more about our data center solutions across the globe, please go ahead and visit us at wesco.com.